Hi friends, once again welcome back on our YouTube channel. This is the next lecture of quantum mechanics in which today we will discuss about Compton effect. Now, what is Compton effect? This whole thing we will discuss here, and this is actually shows the quantum nature of light. So, Compton effect. This effect was discovered by H. Compton. Since Compton effect was discovered by Compton and on the honor of his name, this effect is known as Compton effect. According to it, when a beam of monochromatic X-rays of wavelength lambda is scattered by a light element like carbon, then the scattered X-rays have maximum intensities at two wavelengths, one of them at the same wavelength lambda and the other at slightly longer wavelength lambda dash. And this effect is known as Compton effect. The difference in two wavelengths, that is lambda dash minus lambda, is known as Compton shift. Now we discuss about its theory. So here we are showing a diagram. Here we have an electron which is at rest and a photon incident on this electron. The wavelength of this photon is lambda, and if the frequency of the incident photon is nu, then its energy will be E1, that is h nu, and the momentum of this photon will be P1 equal to h nu by c. Now, when this photon strikes with this element, then we get a scattered photon and a recoil electron. The energy of incident photon is E1, that is h nu. Momentum of incident photon P1 equal to h nu by c, that is E1 upon c. This photon, which photon? This one. This photon strikes with an electron at rest, and the energy of electron at rest is E2, that is m naught c square. M naught c square is the rest mass energy of electron and its momentum is 0 because this electron is at rest. So momentum P2 equal to m into v. Since v equal to 0, so its momentum will be 0. Now, before collision, momentum of electron before collision P2 equal to 0 and energy of electron, that is rest mass energy, E2 equal to m naught c square. Now, this was our diagram. Now, if we think about after collision, then the photon is scattered from its original path by giving some of its kinetic energy to the electron and the electron recoils. Now, after collision, photon is scattered in this direction. It is making an angle theta with the initial direction of photon, that is with x-axis, and the electron recoils in this direction. It makes an angle phi with the initial direction of photon. So, after collision, the energy of scattered photon E1 dash equal to h nu dash. Here nu dash is the frequency of scattered photon, and the momentum of scattered photon P1 dash equal to h nu dash by c. The scattered photon move in a direction making an angle theta with the x-axis. So here we are showing an angle theta. Now after collision, the energy of electron E2 dash equal to mc square, and before collision the energy of electron was E2 equal to m naught c square, that is rest mass energy. But after collision it gains some velocity, so its energy after collision is E2 dash equal to mc square. The momentum of electron after collision P2 dash equal to mv. Here v is the velocity of electron after collision. This electron moves in a direction making an angle phi with the x-axis. So this angle is phi. Now in case of elastic collision, the total kinetic energy of the system remains constant, and also the total linear momentum of the system remains constant. So in each collision, momentum is always conserved. Also energy is also conserved. But in case of elastic collision, the kinetic energy remains constant. Now from the law of conservation of energy, so before collision, the total energy of the system is equal to total energy of the system after collision. So before collision, the total energy is E1 plus E2, and after collision, the total energy is E1 dash plus E2 dash. So from the law of conservation of energy, E1 plus E2 equal to E1 dash plus E2 dash. Since E1 equal to h nu, E2 equal to m naught c square, E1 dash equal to h nu dash, and E2 dash equal to mc square. So h nu plus m naught c square is equal to h nu dash plus mc square. Now if we transfer h nu dash here to here, then mc square equal to h into nu minus nu dash plus m naught c square as it is. So mc square equal to h into nu minus nu dash plus m naught c square. If we square this equation on either side, then m square c raised to 4 is equal to h into nu minus nu dash plus m naught c square whole square. So if we open this by a plus b whole square, then this will be equal to m square c raised to 4 is equal to h square into nu minus nu dash whole square, that is h square into nu square minus twice nu dash plus nu dash square plus m naught square c raised to 4 plus 2h into nu minus nu dash m naught c square. And from the law of conservation of linear momentum, since linear momentum is a vector quantity, so the linear momentum conserve separately along x direction and along y direction. So along x-axis, if we apply the law of conservation of linear momentum, then P1x plus P2x is equal to P1x dash plus P2x dash, and this was our diagram. So P1x equal to h nu by c, because the incident photon move in this direction, means along x direction, and p2x equal to 0, whereas p1x dash is equal to the component of p1 dash along x-axis, that is p1 dash cos theta plus p2x dash, that is the component of p2 dash along x-axis, and it will be p2 dash cos phi. So p1x equal to h nu by c, p2x equal to 0, p1x dash equal to p1 dash cos theta, that is h nu dash by c cos theta. So h nu dash by c cos theta plus p2x dash equal to p2 dash cos phi, that is mv cos phi. So plus mv cos phi. And if we take C as a LCM, then h nu equal to h nu dash cos theta plus MVC cos phi, or this will be equal to MVC cos phi is equal to h into nu minus nu dash cos theta. Now, by applying the law of conservation of linear momentum along y-axis, so P1y plus P2y is equal to P1y dash plus P2y dash. This is the component of P1 along y direction. This is the component of P2 along y direction. This is the component of P1 dash along y direction. And this is the component of P2 dash along y direction. So this was our diagram. Since incident photon is moving along x direction, so its momentum along y direction will be 0. So P1y equal to 0. P2 is already 0, so P2y equal to 0, and P1y dash means the component of P1 dash along y direction. So this will be h nu dash by c sine theta, and P2y dash, that is the component of P2 dash along y direction. So this will be mv sine phi, but if we take the component of this along positive y direction, then this will be minus mv sine phi. So on applying the conservation of linear momentum along y-axis, we get 0 equal to h nu dash by c sine theta minus mv sine phi, or this will be equal to mvc sine phi is equal to h nu dash sine theta. Since mvc cos phi equal to h into nu minus nu dash cos theta, so if we square this equation and this equation and we add, then so on squaring and adding these two equations, we get m square v square c square sin square phi plus m square v square c square cos square phi. So this will be equal to m square v square c square, and in bracket sin square phi plus cos square phi, that is 1. So on left hand side we get m square v square c square, and on right hand side we get h square into nu minus nu dash cos theta whole square plus h square nu dash square sin square theta. So h square into nu minus nu dash cos theta whole square plus h square nu dash square sin square theta. Now if we open this bracket, then this will be equal to nu square plus nu dash square cos square theta minus twice nu dash cos theta. It means here we have h square nu dash square cos square theta, and here h square nu dash square sin square theta. So this will be equal to h square nu dash square, and in bracket cos square theta plus sin square theta, and this will be equal to h square nu dash square. So finally we get m square v square c square is equal to h square, and from here nu square minus twice nu dash cos theta, and also we have nu dash square cos square theta, but here we also have nu dash square sin square theta. So this will be equal to nu dash square. Now we have this equation and also this equation. Now if we subtract this equation from this one, so on subtracting equation 2 from 1, we get m square c square common on left hand side, and in bracket c square minus v square. So m square c square, and in bracket c square minus v square. And if we discuss about right hand side, then here we have h square, and in bracket nu square minus twice nu dash plus nu dash square, and here h square into nu square minus twice nu dash cos theta plus nu dash square. So if we take h square common from this term and this term, then h square, and in bracket nu square minus twice nu dash plus nu dash square minus nu square plus twice nu dash cos theta minus nu dash square. So nu square and nu square will be cancelled out. Nu dash square and nu dash square will also be cancelled out. So here we have h square into minus twice nu dash, and in bracket 1 minus cos theta. So minus 2h square nu dash, and in bracket 1 minus cos theta. And this term, it means m naught square c raised to 4 as it is, and also plus twice h nu minus nu dash m naught c square as it is. Now from relativistic formula, m equal to m naught upon root of 1 minus v square by c square. So m equal to m naught upon root of 1 minus v square by c square. This formula we have derived in our relativistic of mass lecture. Now we cross multiply this equation, and also on squaring we get m square into 1 minus v square by c square equal to m naught square. On taking c square LCM, we get m square into c square minus v square is equal to m naught square c square. And if we multiply this equation with c square on either side, then we get m square c square, and in bracket c square minus v square is equal to m naught square c raised to 4. Now we replace m square c square into c square minus v square by m naught square c raised to 4. So m naught square c raised to 4 and m naught square c raised to 4 will be cancelled out. So we get twice h square nu dash 1 minus cos theta is equal to twice h nu minus nu dash m naught c square. So we get this equation. Now 2 and 2 will be cancelled out. H and 1h will be cancelled out. So nu minus nu dash upon nu dash is equal to h upon m naught c square 1 minus cos theta. So we transfer nu dash from here to here, and m naught c square from here to here. So we get this equation. Or from this equation we get 1 upon nu dash minus 1 upon nu is equal to h upon m naught c square, and in bracket 1 minus cos theta. Now 1 upon nu dash minus 1 upon nu is equal to h upon m naught c square, and in bracket 1 minus cos theta. And if we multiply this equation with c, then c upon nu dash minus c by nu is equal to ch upon m naught c square into 1 minus cos theta. So c and c will be cancelled out. So on right hand side we get h upon m naught c into 1 minus cos theta, or c equal to nu lambda. So c upon nu dash can be replaced by lambda dash, C upon nu can be replaced by lambda. So lambda dash minus lambda is equal to h upon m naught c into 1 minus cos theta, or this will be equal to delta lambda is equal to lambda c 1 minus cos theta. So we replace h upon m naught c by lambda c, and this is known as Compton wavelength. And this equation represents the change in wavelength of X-rays. And this is actually the Compton shift in the wavelength of X-rays. Here lambda c equal to h upon m naught c, and if we substitute the value of h, that is the value of Planck's constant, rest mass of electron and velocity of light, then we get lambda c equal to 0.0242 angstrom, and this lambda c is actually Compton wavelength. So this is Compton wavelength. Now conclusion. Since delta lambda equal to lambda c into 1 minus cos theta, so Compton shift is independent of the wavelength of the incident radiation and nature of the scattering substance. Also, it depends only on the scattering angle theta. Now, special cases, if theta equal to 0 degree, so cos 0 equal to 1 and 1 minus 1 will be 0, so delta lambda equal to 0. So if a scattering angle is 0 degree, then there will be no Compton shift. So delta lambda equal to 0. If theta equal to 90 degree, then cos 90 equal to 0. So delta lambda equal to lambda c. It means in this case, Compton shift will be equal to the Compton wavelength. So delta lambda equal to lambda c, and lambda c equal to 0.0242 angstrom. So delta lambda equal to 0.0242 angstrom. If theta equal to 180 degree, then cos 180 equal to minus 1. So 1 minus of minus 1 will be 2. So delta lambda equal to twice lambda c. So in this case, the Compton shift will be twice of Compton wavelength, or delta lambda equal to 0.0484 angstrom. And it is the maximum value of Compton shift. So Compton shift will be maximum only when the scattering angle theta equal to 180 degree. Now experimental setup. If we want to do this practical in our laboratory, then what is the experimental arrangement? This thing we will discuss here. So this is our experimental setup. Here we have source of monochromatic X-rays. Here we have slit. This is the graphite, that is the scattering material. Here we have Bragg's spectrometer, which can be rotated on a circular turntable. So this dotted line showing the path of spectrometer. Now X-rays come from source of monochromatic X-rays, and this X-ray in the form of fine beam incident on this material, and after scattering from this material, the X-rays is scattered in different directions and its intensity can be recorded with the help of spectrometer, because this Bragg's spectrometer can be moved on this path. So this is the path of spectrometer. So at different angle of scattering, we can get the intensity of monochromatic X-rays. Now if we draw a curve between wavelength and relative intensity at different scattering angle, then when theta equal to 0, then there will be no Compton shift. So this will be unmodified radiation. But as the value of scattering angle increases, the difference between two wavelengths also increases. So this is the curve at theta equal to 45 degree. This is the curve at theta equal to 90 degree. And this is the curve at theta equal to 135 degree. So as the value of theta increases, the difference between two wavelengths, that is lambda and lambda dash, or the Compton shift increases, and it is the maximum at theta equal to 180 degree. And after theta equal to 180 degree, if we increase further the value of scattering angle, then the Compton shift reduces again. So the excellent agreement between the Compton shift obtained from Compton theory and the experimental results confirms that the elastic collision between a photon and an electron is just like an elastic collision between two particles. It proves the quantum theory, that is the particle nature of radiation. So here we end our session. In the current session, we have discussed about Compton shift. So goodbye.